Hi everyone. So we're going to start now. Welcome to Astronomy Lesson 3. Today we're just going to be talking about some interesting facts about space and the Milky Way galaxy. There isn't a specific subject that we're going to cover today. Now, most people know this, but to be more specific, space is the area beyond the upper limits of Earth's atmosphere. It's where all of our asteroids, comets, planets, stars, solar systems, and galaxies in our universe are found. Now, the temperature in space is extremely cold. It's about negative 270 degrees Celsius. And the reason outer space is so cold is because there's no source of heat nearby. For us specifically, we are pretty close to a star that radiates a lot of heat and energy, which is why, and we have an atmosphere that traps that heat, which is why we have a normal high temperature. But in the giant void of space, it's spread out so large that there isn't any source of heat that would be able to heat it. Space is so large and empty that any object placed in space can radiate a limitless amount of energy in all directions, but if there is no sun to warm it up, it will eventually lose all its heat and grow very cold. Space is also a hard vacuum, meaning it is a void that contains very little matter. Being a vacuum means that the atmospheric pressure is extremely low, and more specifically, this means that parts of space that are far away from planets, stars, and other things are nearly a vacuum, meaning the concentration of particles in the regions between planets and stars is very, very small compared to the concentration in our atmosphere, like on Earth. Because the concentration of the particles is extremely low, that means that the pressure is also very low, which makes it a vacuum. There is also no sound in space because molecules are too far apart to transmit sound, which ties back into space being a vacuum and having a low concentration of particles. The space between galaxies is not completely empty again, but it has an average of 1 atom per cubic meter, which is a very, very low concentration. If you think about it, 1 cubic meter is a 3 by 3 by 3 foot of space, and there's 1 atom in that space. Now, there are an estimated 100 to 400 billion stars in our galaxy, the Milky Way galaxy, which is about average or a little bit above average size for a galaxy. And in the observable universe, there are an estimated 2 trillion galaxies. Now, in our solar system, in the Milky Way, 194 moons, 3,583 comets, and 796,289 asteroids have been found in our specific solar system, which is our sun and our planets. orbiting the sun. Now, spacecraft from Earth have visited all the known planets in our solar system. An example of this is Voyager 2, which is a space probe that was launched by NASA on August 20th, 1977. And this space probe was specifically sent to study the outer planets. There was also a Voyager 1, which was sent out into space and was sent to study other planets as well, but Voyager 2 was specifically sent for the outer planets. And Voyager 2 visited Uranus, the seventh planet from the Sun, in January of 1986 by flying within around 50,000 miles of Uranus's cloud tops. Voyager 2 also visited Neptune in August of 1989, 3 years later, passing within 3,000 kilometers of the planet's north pole. Both Voyager 1 and Voyager 2 are continuing to go farther out into space as we speak, and we will lose contact with Voyager 2 after it is about 15 billion miles away, I believe. Now, the Milky Way, which is our galaxy, began forming around 12 billion years ago and is part of a group of about 50 galaxies that NASA has called the Local Group. The Andromeda Galaxy is part of this group, as well as other smaller galaxies, including the Magellanic Clouds. Now, the large group itself is part of another larger gathering of galaxies called the Virgo Supercluster of Galaxies. The Milky Way has grown over time by merging with other galaxies. Merging with smaller ones allowed it to grow in size. And it is currently acquiring stars from a small galaxy called the Sagittarius Dwarf Spheroidal. And it also attracts material from the Magellanic Clouds, which I mentioned was also part of the Local Group. So the Milky Way is expanding and merging with these smaller galaxies and becoming larger. Now, the Milky Way's central core contains a supermassive black hole. Scientists have named it Sagittarius A, and it contains the mass of about 4.3 million suns. Now, our galaxy will collide with the Andromeda Galaxy in about 5 billion years. Some astronomers refer to our two galaxies as a binary system of giant spirals. Just like how our Milky Way is merging with other smaller galaxies, the Andromeda Galaxy is around the same size as our galaxy. So when it collides, there will be no merge of the two galaxies, but both of them will be destroyed and a new one will form. This new elliptical supergalaxy will be formed by the collision of the Milky Way and Andromeda Galaxy. And on the left, there is an illustration sequence that was created by NASA, which is just an image of an imagination of what will actually happen. So that was all of today's lesson. If anyone has any questions, don't be shy and you can unmute or put them in the chat. Thank you to everyone who tuned in today. Next week, we will be learning about the life and death of stars and the cycle that each star goes through and what stage the sun is at and all these other things about the life and death of stars.